Okay, still on first. Okay, it's on already. So you must have ZT first, isn't it? ZT is just write down ZT is equal to what? R1. Now remember the C, there's a top. There's a 1 at the top. 1 over S C, okay, plus R2. Now that is the total impedance for the system. Total impedance ZT. And then we want to find VO, isn't it? So using potential divider or using voltage divider theory, it will be VO equals R2 over ZT times V in VI. This is how you find the value for VO lah. R2 over ZT. Then this is equal to R2 divided by R1 plus one over S C plus R2. This is how you find the VO. You do like this. Of course, don't forget the VI there. There's a VI here. VI. This is how you do it. Then you can simplify to R2 divided by R1S, isn't it? R1 S plus 1 plus R2S I think I left out something there. I left out the C, SC. That's why I'm thinking why like that. Left out the C, put the C there. So this is R1SC. Erase it first. R1SC R1SC plus 1 plus R2SC. Now this is how you find the what lah. Yep. So I just delete first. R2SC SC. Of course, the top will have SC lah. R2SC. Oh, am I right? Let me see. Yeah, R2SC. Then you have this VI, isn't it? Check first. Yeah, it's correct already. So you want the transfer function will be VO divided by VI. Make sure you put the thing is some book they put the S, some don't put. So this time I will accept it. Last time you don't put the S. I deduct mark today, but I saw also some book, sometimes they put, sometimes don't put. The S, I mean, now there's an S here. Now this time you put or don't put, I will take it to be correct. Some book put, some book didn't put it. So I don't know. By right, it should be there because this is S domain. But some book they just don't put. So whether you put or don't put, I will accept it this time. Last time the student didn't put, I will deduct 1 mark like that. So this is actually equal to R2 S C R1 S C plus 1 plus R2 S C. This is how you find the transfer function. So after that, you can substitute. Now there's no space. I have to clear the thing first. Now the values of C, R1, R2, they are given to you, see? So you just substitute. So you also remember, you must also remember S equal to, just substitute. Okay. You just substitute, you say, now this is given to you, R1 equal 1 ohm, R2 equal 2 ohm, and C equal to 1 farad. The S won't be given to you. The S assume that you know the value for S. I just give it to you here. You have to memorize the S. S equal 2 pi F J or equal to omega J also can. Omega is 2 pi F. We study in year 1. Omega is 2 pi F. You can say S equal omega J or S equal 2 pi F J. So you substitute all this value. Now I just show you the thing. I won't do it because calculation is too long. You can substitute at home there. So after you substitute, you look at the left hand screen there. After you substitute, you got VO over VI equal to 1S. And then you got this 2 pi 10 J. Frequency is 10, I think. Yeah, frequency is 10. That's why the 10 come out. So I give you also frequency. F equal to 10. F equal 10 hertz. So the basic one will be like this. After you substitute, after you work out the formula, then you look at the left hand screen there. I will just copy out. I think I will just copy out. No, I leave it like that. So you see the left hand screen. Just make it like that first. Left hand screen after substitution will be like this. R2 is 2. 1 is C, isn't it? Yes, C is 1 farad. So substitute, you got a J there, isn't it? You got a J. Now you want to divide that one J at the top, another J at the bottom. You want to divide. So what you do is you take the conjugate of the bottom one, the conjugate of 1 plus 188.496J is 1 minus 188.496J. So you do like that. Then you got, actually the bottom part is 1 minus 188.496J squared. Just to remind you, J squared you go to 1. Actually you got something like this. The bottom one is, you know, last time in school we do something like that, isn't it? Form 5 the time. A plus B bracket. Last time Form 5 the time we do something like this. I think Form 3 also do already. This one, A minus B, isn't it? When you have this kind of thing, you can just simplify to A square minus B square. But now there's something different here. There's a J there, because you got a J. You got a J here. You also got a J here. So what happened is, because you got 2J there, you got a J square there. You got J square there. J square. Because you got J square, you can say that equal to A square plus B square. Because J square, just put here first. J, this one, it won't be given to you. This formula, J square, you have to memorize it yourself. J square equal to 1. J square equal to 1. That's why I got this A square plus B square. The negative side will become positive. So it become A square plus B square. That's why on the left hand screen, you got this 1 square plus 188.496 square. Then take the modulus will be, you take the modulus of the upper part. Then because the bottom is constant, just take the modulus of the upper part. Then you got 0.667. Now to find the dB, you have to memorize this formula. So dB formulas like this. This one won't be given to you. dB is 20 log. So this one you must memorize it. Log V output over V input. Now this one you have to memorize it. Will give you dB. Usually it's negative one. I mean, in this kind of filter calculation, usually it's negative dB. Now this is how you do it. So on the left hand screen, we got minus 3.51 dB. That's the final answer. Final answer is minus 3.51 dB. It's here, the bottom left hand screen, the bottom line there. Now this is how you calculate the dB, because the question asks you to find transfer function and gain, and gain in dB. The gain is, I better mention first. Now the gain means, on the right hand screen, definition for gain is Actually, same as transfer function, right? Also VO, VO over VI. This is a formula for gain. Just remember it. Also same as a transfer function. Transfer function also VO over VI. So let's highlight this one, circle for you. The gain is VO over VI. Well, otherwise, somebody will ask how to find the gain. Gain is actually same as transfer function, the formula. So you just take the 20 log VO over VI, then you get the answer, minus 3.51 dB. If they don't ask you for dB, it will be what? It will be, if they don't ask you for dB, it will be 0.667. I just write out here for you first. Look at the right hand screen there. If they ask you for gain, it will be just like that, right? 0.6. After calculation, before you times 20 log, this is the answer. If they ask you for gain without the dB, usually they will ask you for dB just to test you whether you understand the meaning of dB. dB means you, right hand screen here, dB means you go and times 20 log. VO, VI times, take the log first and then times 20. That will become dB. Now this is the first example here. Let us look at the second example. Second example, now you don't call this one low pass filter, high pass filter. There's nothing like that anymore. They are just filter network. They are just filter network. I clear the screen. Clear the screen. I'm going to do this one. I won't do the whole thing. I just do the basic one, the basic formula come out. I just capture this one. I just run this one. You have to find the differential equation. Copy first. Now, this question here, you need to do two things. The two things you need to do will be find. You have to find transfer function first. You can't find the differential equation first. It won't work. Find. Transfer function and differential equation. Two things are, you cannot find differential equation first. It won't work. You must find the transfer function first and then find the differential equation. Now, how to do it? So you start off by saying ZT equal what? You say ZT equals L doesn't have the one at the top. You just go and put SL lah. SL1, okay? Just put S in front, that's all. Only the C got the one at the top. This is how you memorize it. Then of course you got SL2 lah. SL2, and then you got resistor there, R there, plus R. So this is the total impedance of the circuit. Now I want the VO. So I want VO, it will be what? It will be, if I want VO, I have to take the bottom impedance, then the bottom impedance will be, I do like that first. VO equals, bottom impedance is SL2 2 plus R divided by ZT. This is how we do it. So we solve for ZT first. There's a VI there. Don't forget the V. This is using the voltage divider theory. Voltage divider theory, take the bottom impedance or take the bottom resistance divided by the total resistance or total impedance. This is what you study in year 1. The voltage divider or potential divider theory is like that. And then now we have to do the ZT. So ZT also wrong, isn't it? Then let me see. Yeah, it's correct. ZT is correct. So we go and calculate ZT first. ZT is equal to S square. Now the S square coming in already, is it? Do step by step. Otherwise you don't see the thing. S square L1C S square L1C plus 1 plus S square L2C, okay, plus R S C divide the whole thing by C. Right, this is the total impedance. So total impedance you have already. Then you have to use a SL V naught equal what? V naught equal SL2 L2 plus R divided by the whole thing there. Divided by S L S square, the square coming in. Very hard to write the name. Clear this one first, it's very bad. So S square S L so S square here, S square L 1 C plus 1 plus S square L 2 C plus RSC. Now don't forget the SC. SC will go to the top. So I put a bracket here. SC. Right. So of course you have the VI there. VI. So this is the output voltage VO. You get the output voltage like this. Then you can go and simplify the thing. Simplify the thing will be just erase it first. Erase it. This one also can go lah. Right, erase it. I push this up. Push it up. Right, push up already. So the transfer function is V naught over Vi, isn't it? Just do like that first. So transfer function is V naught over V. Now whether you put S or don't put S, I don't care this time. I noticed some also never put. Some put, some don't put. They bracket S. Usually this is what we do lah. But this time whether you put or not, it's up to you lah. Equal to, I simplify in my head lah. S square L2C, isn't it? S square L2C plus RSC SC. So bottom will be same now. Bottom is S square L1C plus 1 plus S square L2 C plus R S C, and that's it. This is a transfer function equal to transfer function. Okay, equal to transfer function. So we get the transfer function. Now we have to find this the differential equation. Differential equation. Remember last time I said d over dt is S, isn't it? That kind of thing, is it? So now for differential equation, you must put in the S. You don't put S, very hard to do one. Because last time sometimes you must put S, sometimes no need to put S also can. But in this case, put in the S. You don't put S, it won't work out, okay? Just put the S there. So what you do is you cross multiply. Cross multiply will be you start with the constant first. L1C, isn't it? Or CL1 also can. I think I better follow the order. Otherwise, some of you may ask how come like that. Follow the order for you. So you cross multiply and convert back to differential equation. Now the S square thing you put last. The VOS you have to put last. So I start with the constant term first. L1C. Then you have this S square. If you follow in order, everything will come out very easily. V naught S. Cross multiply now plus V naught S, isn't it? V